All right, hello everybody. I'm coming up on 4 o'clock, and sometimes I end up taking a little too much time to get through slides, so I think I'm going to go ahead and get started. Thank you for joining me for a webinar on dyslexia. This webinar is part of the Behavioral Alliance series of webinars. Today I'm going to talk about dyslexia history, policy, and school-based practice. And my name is Scott Decker. I'm at the University of South Carolina. Let's start with a definition of dyslexia. Dyslexia, this is a definition provided by the International Dyslexia Association. Dyslexia is a specific learning disability that is neurobiological in origin and characterized by fluent word recognition problems, mainly from a phonological component of language. So I want to emphasize that. And we're going to dive into this a little bit more here in a second. Let me just say that there are differing definitions, and the definition of dyslexia has changed over time. So one thing that's been known, at least from IDA definitions, is that we know phonological processing is an important component. But now more modern definitions, as supported by research, has broadened the range at which phonological deficits can contribute to a variety of reading problems, not just word reading, but decoding, accuracy, and fluency. So what I'd like to do is, instead of giving you too much of a background on my research, most of my research is on kind of using brain-based perspectives to understand problems in education. And part of my research looks at neurological signatures to predict learning disabilities in children. The kind of areas that I'm interested in are learning disabilities, ADHD, and traumatic brain injuries. But I want to kind of take a little bit of a detour to define a little bit better what these definitions, which have historically always said neurobiological in origins. And I want to try to provide a neurobiological explanation for dyslexia. And to do so, I'm going to go through just a little bit about kind of general brain functioning. And I like this slide here. This is looking at the brain as if you were underneath the brain. And you can probably see little wires. I don't know if my cursor works here, but if you can see these little wires here, this top wire up here where you see these kind of two things crossing is called the optic chiasm. And this is a nerve that's actually connected to your eyeball. So when you see things, information's being relayed from this nerve, the optic nerve, to the lateral geniculate nucleus. This is this middle relay station. And then it fans out into this pattern of these like little fibers, and it looks very much kind of like wires. And this is somewhat of an instructive component to understanding how the brain works, in that the brain is connected through these different, what I'll just refer to as wires. They're not actual wires, but they function much like wires, like what are connecting your computer right now. Brains don't have Wi-Fi. So they had to work through these wires, which are insulated, just like the cords, your electrical cords connecting your different appliances, to help eliminate interference. And these wires project to certain areas of the brain, which become specialized for processing certain types of information. In this specific case, this is the visual system. So information comes in from your eyes down these nerves to the back of the brain. This is a neat little diagram here to show what are called hemianopias. So if you have specific injuries to certain patterns of these wires, you will have visual deficits. Now, obviously, if you have one nerve to the eyeball cut, you'll have monocular blindness. That is, you will not be able to see out of one eye. However, a different pattern will emerge in visual deficits based on the specific types of injuries to the structural components of the visual system. Now, the take-home message to this is, this is kind of the basis of neuropsychological analysis of behavior, is that through different assessment procedures, you can test different types of visual deficits and then make an inference as to how the brain is functioning based on the pattern of deficits. And so we know that this is a very clear pattern of visual deficits that emerge based on very specific types of brain injuries that you get. And typically you don't see this. This has nothing to do with learning disabilities. This is just the kind of more instructional component. You do see these types of deficits usually with something like stroke or some type of focal lesion in the brain, tumors as well. Now, in addition to these, those were the subcortical pathways, you have the cortex of the brain, and the cortex of the brain also has a division of labor. So you can see in this diagram at the very back of the brain is the visual cortex. The reason why that's called the process is because the little wires that I just showed you on the previous slide carry the information to the back part of the brain. However, that same type of structure applies to the rest of the brain. So that you can see along the temporal lobes here is auditory processing. And the reason why it's auditory is because you have nerves connecting your ear to this part of the brain. You also have motor cortex, which is movements of the body, as well as somatosensory areas which register touch and touch sensation from your body. And your body is mapped out on across these two little lobes. And then you also have the parietal lobe, which is also is involved with somatosensory processing, as well as some intermodal integration, that's combining visual and auditory, somatosensory and visual processing as well. And this, again, is just kind of a quick overview of how the brain works in terms of its functioning. Now, what's interesting is even at the cortex, you can see from the bottom left picture here, this is a picture of the arcuate fasciculus, which kind of looks like kind of these little pathways. And this pathway is important because this is the pathway that carries language from the back of the brain to the front of the brain. Now, most people have probably seen in a Psych 101 textbook, the back of the brain with the little words Wernicke's region, and the front of the brain with Broca. The back of the brain is oftentimes, the back left part of the brain, the Wernicke's region, is involved with language processing or language reception. The front part of the brain, the Broca's region, is involved with language expression. That is actually getting language out of your mouth. But as you can see, this doesn't happen mysteriously. That is, the language that you process through receptive means, back of the brain, has to then go to the front of the brain to be expressed. Again, the brain doesn't have Wi-Fi, so it relies on these fiber tracks. That's these basic little tracks you see at the bottom left. And then we can create these little diagrams that you see in this top right part that show how information flows. And I think that's an important concept to get out of this kind of understanding of how the brain works, is that you have different regions of the brain that are specific for processing certain types of information. Once processed, that information flows to different regions of the brain to be integrated with other functions. And that these regions, this information transfer occurs through structures of the brain, such as these big wires. I like to call these interstates of the brain. Now, this is a more modern view of from research that's told us, well, exactly how is this cortex? What are the different parts of the cortex that's processing information? And one of the real breakthroughs in neuroscience has come from understanding the cortex as an interconnected network. So when you think of a network, think of something like the airport system in the country that you have some airports like I'm here in Columbia, South Carolina, which has a great airport, but it's really small. But it connects to larger airports like Charlotte and Atlanta. Those are major hubs. Now, what this view is telling us about the brain is very similar to how the analogy of how airplane systems work. Now, if the airport here in Columbia were to go down and break, it's not really going to disrupt airplane traffic across America very much. However, if a place like Chicago or Atlanta or here over in Charlotte, if those airport systems go down, that's a major hub. And that's going to cause large-scale disruption of the airport, of air traveling in the country. Well, this is very similar to how brain injuries work and how when we get cortical disruptions or we have things like learning disabilities, which is what I'm going to talk about, is that you can look at how information flows between hubs as indicators of what types of systems are breaking down that are causing different types of learning problems in children. So again, this is just kind of a bit of a metaphor. We've got all sorts of science now, whereas we had to rely on structural imaging previously through dissections. We now have functional MRIs, which you see here to the right, which can do non-invasive mappings of these types of networks. So the science has really taken off in the last 20 years of mapping out not only the different networks, but how networks might differ across different people, across different cultures, and also in individuals in comparison, normal kind of standard children without learning disabilities to children with learning disabilities. We've also found research, you can see that these networks oftentimes get started in very early stages of development. So language processing, for example, networks appear to be almost already started when a child's born. So some of these networks and structures to these networks are probably genetically influenced. So you oftentimes hear, well, language development is somewhat genetic. But really what that means is there's a gene that just predisposes brain networks to form to start processing language information. And again, this is very important at very early stages in life when a child's brain is primarily decoding the sounds that they're hearing from other people to start forming language networks. And again, we could use fMRI of children to start seeing how these little networks are forming and how these little hubs in the network are starting to organize. And we could also look at, this is from a meta-analytics study of brain networks of language across different cultures for kids who speak English versus Chinese versus Japanese. And you can see that there's actually a kind of culturally invariant, meaning the basic language structures in individuals form the same way regardless of the type of language you speak. There are oftentimes some there are individual differences across cultures, meaning, so for example, Chinese language, for example, has more orthographic characteristics and less phonological characteristics, and that requires different brain regions. But in general, just for orally spoken language, there's a kind of invariant pattern across cultures. Now, this is where, this is my research interest, and what I want to kind of communicate today is my view of learning disabilities, specifically for reading problems, comes from trying to understand the cognitive processes involved with reading, such that when you have a child who for some reason appears to be delayed in reading for reasons that don't appear to be related to exposure to language, opportunity to learn, general intelligence, all these other factors that you roll out, that we could start looking at specific cognitive processes that might be breaking down that's causing the difficulties in learning. And so my perspective then is, when I think of things like learning disabilities, and not just learning disabilities, but also when we talk about emotions of children and mental health and emotions like anger and frustration, what I start thinking of is how are these systems working in the brain? How do they relate to behavior? How do we assess and test these different types of behavior to then make inferences to help children in schools to become more adaptive? Part of this then, and this is also a kind of um, a perspective view of thinking about teaching children, maybe not just for reading, but for all subjects, because trying to improve children's learning ability is of interest to educators as well as a large number of other professions out there, is that the important part is to break down the task that you want the child to learn into more basic elements. So when we look at reading, we can break it down into things like, obviously, visual is important, meaning if a child cannot see text, they're going to be impaired in reading. That makes total sense. But there's also components of language, meaning that a child has to have a network of language already embedded in their brain. And then what appears to be more important then for reading is this process called phonology. So phonology is that language network that can break down language into specific sounds. So for example, the word dog has 3 sounds to it: d, ah, g. Those are all phonemes. Now, the phonological processing then is the capability of a child's brain to hear those distinct individual sounds. The reason why that is important to hear the distinct individual sounds is because when you learn to read by associating those sounds onto specific visual orthographies, or what are also called graphemes, which are fundamental units of words. So now, not all words could be read through phonological processing, that is breaking down the word into sound structures. There are some words that have to be learned through sight, and those are called orthographic. These two processes, orthography and phonology, play off of each other throughout development in learning to read. These two steps of involved with reading decoding, that is decoding words, are essential for what's called semantic access. So semantic access is having a vocabulary of words. So for example, if I said, define the following word, d, a, g. Well, if you couldn't blend those sounds together to form the word dog, you wouldn't be able to access your memory of what a dog is, which once you hear the word dog, you can say, oh, it's a type of animal, it's a pet, I like to pet it, eats food, et cetera, et cetera. Well, that means you've now accessed your semantic network. This is your memory that stores knowledge of specific words. And then oftentimes you now have to express the words or talk, or if you're reading out loud, you have to say the words. And so what we can do with this is break down, you see the stages, there's a kind of input, you got to see something. There's a processing stages, and there's multiple processing stages. That is, you have to decode the word before you can semantically access it. And then if you're reading, you have to orally express it. And this is the stage at which these processes occur. Well, this is again where neurocognitive research can help us out. In neurocognitive research, there have been a number of studies that have taken these different stages and different models. So you can see at the bottom here is that we can postulate, well, there's a semantic system and there's a phonological system, there are letter units. And then you could postulate another type of model like the triangle model and say, well, no, this is how these 3 systems work. And then you can collect data to look at the brain to see if there are corresponding brain areas that become activated for these different components, which it turns out there is. So there have been a number of studies that I'll look at, and this is a rough overview of different studies. The details aren't important. The important aspects of this are research has been able to not only break down learning tasks such as reading, but also able to map different components of reading onto specific brain regions, so that these regions of processing, of how information's processed in certain regions, then it has to flow to another region, have been pretty well defined through a number of research studies. These research studies have greatly contributed to then our understanding of what dyslexia is. And one study from Shayowitz, and this has been replicated a number of times, is there's been an identification of what in this paper called posterior brain systems. But really, if you look at that little brain area, what you're seeing is 3 of those brain areas, one for kind of decoding visual words, one for phonological processing, and then that front part, which also involves the language expression part, that these parts of the brain are not as interconnected in children with dyslexia. So when we say something, or you read a headline like posterior brain system for reading disrupted, really what that means is there are certain parts of the brain that are processing certain types of information, and those parts of the brain might be working fine. However, those parts of the brain are not well connected to other parts of the brain. Thus, the information being processed is not going to other brain regions to form a kind of network of cognition that is used for the academic performance, in this case reading, but really this applies to all areas, which includes math, spelling, writing, and forms of cognition like attention, executive functions, all of these things. So there have been a number of studies that can even more precisely locate phonological disruption problems to parts of the brain, which again, a number of research studies have identified left side of the brain. Again, this why left side of the brain is because this is part of the language network, and the language network is involved with language phonemes and differentiating language phonemes. It's on the left side of the brain, and it involves these different brain regions that are involved with the visual association of language phonemes for that then go into accessing semantic memory, so that you, once you read the word, you understand what the word means, and you're able to read the word and understand the word within a context of a sentence. And so there have been a number of studies that have looked at brain activation patterns that have compared children with normal developmental reading trajectories with children who have dyslexia or other types of reading impairment. And we see that there are differences in these brain regions. So this gives us pretty good evidence that these brain regions are heavily involved and heavily involved with developmental dyslexia. And again, you could see this in a number of studies that have gone on to look at occipital temporal. So this is a more specific region that's also part of this language network. But this study is very interesting because it demonstrated that if you give the child, if you give a child who has reading impairment due to phonological processing, phonological interventions, then rescan their brain, and that you got evidence to demonstrate the phonological intervention worked and the child's reading started developing closer to that of a normally developing child, their brain region then starts to look like a normally developing child. What this tells us is that these brain regions are not just correlated, they're causal. That is, if these brain regions don't work, it's going to be very difficult to read. If you use an intervention to target the functionality of these brain regions and you get these brain regions to work, all of a sudden reading takes off. Again, very important types of series of studies. And again, this is all for the purpose of kind of giving you a little bit of background of now, if you look back at the definition I gave you for dyslexia, to say it's neurobiological in origin, which by the way has been part of the definition of dyslexia for over a century, meaning people knew the reading deficits involved with what we call dyslexia were neurobiological, meaning it's something in the kid's head that's not working right or processing the information, has always been known, but it's only been within the last 10 to 20 years, maybe even more recent than that, that we've been able to really get a causal model of the specific brain regions that are causally implicated in dyslexia. And so you can now understand that the neurobiological part of it, and also why phonology is such an important component of how it's working in the brain. And then you can even add to this now that dyslexia is a learning disability that results from reduced connectivity in brain regions involved with the associative learning of language sounds. And so dyslexia is, I think, something of a good example of a learning disability of which science has just recently really shed a lot of light onto the exact mechanisms that might be causing the learning problems that will likely be the paradigm or the model we use to now understand all types of learning disabilities, but also that can be generalized to even other things like mental health disorders and the emotional systems of the brain. Okay, so that's a little bit, hopefully that gives you a little bit better understanding of dyslexia, or at least how I use the word dyslexia and understand it. Now we can go into a little bit of a historic context then, and starting even back, the word dyslexia was first used to identify kids with unusual patterns of reading back in 1887 by Rudolf Berlin. So it's been over a century since this kind of learning problem's been recognized. However, it really wasn't until a conference in Chicago organized by parent advocates, and that's something of a important piece of information here. Parent advocates in the 1960s whose children would go to schools, and at the time, there were no services for kids with learning disabilities. So they organized a conference, invited Samuel Kirk to speak at the conference, and he used the term specific learning disability. And that was the term that the parent advocates ran with and then used to advocate for changes in federal regulations to special ed to add learning disabilities as a specific category of disability for special education. And again, even Samuel Kirk's original definition involves something that a diagnostician is required to really understand these specific problems. Although even back then, it really was, the neurobiological patterns involved really weren't well understood. But he did see it, what I thought was an interesting insight, as a developmental imbalance, meaning children with dyslexia differ from other children in that, if you think back now to the network parts of the brain, all the other networks of the brain work and they are developing within normal developmental expectations. However, it's a very subset of those networks that are not developing along expected guidelines. And that's really what people started to see as the developmental imbalance. And we can define it, I think, now a little better by thinking of those brain networks. And again, this was part of, Samuel Kirk coined the term specific learning disability in 1969, that then led to Public Law 94-142, which then required schools to identify children with learning disabilities and provide special education. And that's why identifying learning disabilities is such a major issue in schools right now. At the time, again, there was not a very well-developed body of research saying what, to understand exactly what a learning disability was, the causal mechanisms involved, and also how should we identify these kids. At the time, and this somewhat still holds true, is that a learning disability is defined by unexpected problems in learning. The unexpected part comes from the child learns according to normal developmental parameters and everything else, except a specific area of school, which is why it's unexpected. It's like, this is a smart child. They're smart at everything else. Why can't they learn to read? And this also ties into the unexpectedness of what brings on some of the major behavioral and mental health problems you see in this population of children, which is the unexpectedness is almost default explained by both parents and teachers as laziness, opposition, lack of opportunity to learn, and all of these other explanations that are faulty. And oftentimes, again, the most common explanation for these problems are usually something like laziness and opposition, which then cause a great deal of stress to kids that then starts coming out into other areas of school. But back then, the problem was, well, we have to define this unexpectedness and measure it, or there's no way that we can have a special ed category, or else if there's no criteria to define who's in and who's out, it runs the risk of being of too many kids being identified. So they said, well, these are smart kids that are having trouble in one area. So SMART is IQ test. The learning area is an achievement test. So how about we subtract the IQ score from the achievement score, and you get the discrepancy method, which has been used in schools for over 30 years to identify kids with learning problems, and including children with learning disabilities and reading, which includes dyslexia. And almost from the start, there were problems with this method. Some of the problems are psychometric, meaning you get biased estimates if you subtract two scores. It depends, should you use raw score, standard scores? But the real problem here there are other more major problems, which are just taking an IQ score from an achievement score doesn't tell you what intervention you should do. It kind of says, okay, you've met criteria, but it doesn't really tell us why you can't learn. Part of the reason for that is the way IQ tests are made. Now IQ tests measure so many different cognitive abilities, it's really not accurate to put different cognitive abilities all compiled together into one score that we call IQ. So the problem is in how cognitive ability measures developed over time, because a lot of these IQ tests, take for example the Woodcock-Johnson, part of the IQ is made of tests involving phonological processing. Well, if those are the region or the abilities that are impacted by this disability, it's going to lower the IQ score, which reduces the chances of getting a discrepancy, which again, it speaks to the problems that you can have with this approach. And, but nonetheless, this approach was the way that children were identified from 1975 to 2004. And I think for the most part, school personnel made it work. Exceptions could be made, and a lot of exceptions have been made for individual kids. But it was good enough. In the late 1990s, it was recognized that the category of learning disability, which by the way, learning disabilities is the highest percentage of kids in special ed. And from the time it was started in the 1970s to the late 1990s, it was recognized that it was escalating in identification rate, and that researchers at the time just projected the line. So you can see by this graph, if you take the rate of learning disabilities between this time period and just draw a simple line through it, you can see that it's going to escalate over time. And with one other caveat, that children in special ed oftentimes have a higher financial cost in education. You'd see that the financial costs in education are going to increase over time. So LD is expensive, It's increasing over time. So in 2002, right after the 1990s, when this was discovered, there was a House hearing to reform guidelines in identifying children with learning disabilities. During that hearing, a number of people testified, and again, part of this was, it was during the hearing, it was very evident that the associated cost with learning disabilities identification was an issue. But it was believed at the time that it might be due to the use of the IQ achievement discrepancy method, and that we're going to have to change it because it's causing an inflation in LD rates. Part of the solution then was to provide early interventions through a response to intervention, which we now have kind of response to intervention first came into law under learning disabilities. And we now see it as a multi-tiered model, although the idea of tiers wasn't necessarily directly defined within the law for RTI. And at the time, there were a few studies suggesting that providing structured interventions would improve learning outcomes such that it could reduce special education classification by 20 or 30%. So this sounded like a good idea. So if you look at the SLD federal guidelines today, the first criteria is you don't have to use the IQ achievement discrepancy for reasons that now make sense. Hopefully you can use how a child responds to scientific-based research interventions, or C, you can kind of use whatever you want so long as there's research to support it. Interesting, kind of like with the IQ achievement discrepancy approach, there wasn't a lot of research prior to 2004 to support the use of a response to intervention to appropriately identify children with learning disabilities or any other disability for that matter. Interesting that what happened though, even before the law was enacted, is the rate of learning disabilities rapidly plateaued and then started to decline. So again, the federal law didn't come out until 2004, but you can see by this blue line on the chart that the rate of learning disabilities has drastically changed. Nobody knows the reason why. We can speculate, but there's no clear reason as to why there was this really rapid change in the rate of learning disabilities. And also, you can see from the chart on the left, if you look at every single state from the years 2006 to 2011, the rate of LD reduced in every single state. And the color coding scheme here is just to show that in blue states it reduced the most, and in yellowish or the kind of orangish is less. But it overall reduced all over the country, and you can see it by this graph. Very interesting. And again, researchers are still trying to figure this out. We can speculate on it, but we don't need to. So RTI, meaning put into as an approach to reduce special ed while the rate was already going down, might have resulted in some problems. So in 2011, this is about the time all the schools started using response to intervention. The Office of Special Education got notice that children with learning disabilities were not being identified, or their identification was being delayed. And this is the memo that was sent to all special educators across the US, indicating that this problem was emerging. There were some other problems as well. Again, at the time, when it was introduced into federal law, there wasn't a lot of research highly supporting the use of an intervention response approach, almost zero research to accurately identify a disability, some research to support educational outcomes, but there weren't any large-scale studies. The first large-scale study was just conducted in 2015. In the study, 13 different states, which included over 146 schools using RTI for 3 years, had at least multiple tiers of which different levels of instruction were being given to at-risk students. So it had all the major components of a multi-tiered response to intervention approach. And if you see this is the effect size that is the amount of increase in educational outcomes, with zero meaning zero and below zero meaning there were nothing to negative outcomes, and everything above zero were positive outcomes. This is the overall effect size for all the schools, where you can see that there's an alarming large percentage of schools of which academic outcomes are not being improved, and even more alarming of which there's a high number of RTI outcomes that are resulting in negative impacts. Again, nobody knows exactly what's going on in the use of, in the comparison here is kids getting a multi-tiered intervention approach in comparison to other kids who need intervention, but it's not being done in a multi-tiered or a response to intervention methodology. That the number of children resulting in negative outcomes are outweighing the number of children getting positive outcomes. I use this to kind of suggest another phenomenon that we're getting in dyslexia right now, which is that there are parent advocates emerging all over the country who are enacting specific laws to identify children with dyslexia. And approximately right now, about over 45, 46 states have adopted specific laws to mandate schools to identify kids with dyslexia. Well, why is this emerging? One possibility from the information that I've provided is that schools are really struggling with implementing with fidelity a multi-tiered model for the purpose of identification of children with disabilities. So that was enacted in federal law, then implemented within schools, and you can, I'm kind of following this pathway that I'm seeing, I have on the left side here, which are then directly impacts children. Parents are witnessing the outcomes, not liking it, and then they're starting to advocate for change. And this is the kind of cycle that I've seen with dyslexia, that if you recall back in the 1960s and 70s, it was parent advocates who lobbied federal regulators to put LD as a category to begin with. And it was because they were seeing their children struggle in schools. And now we're seeing it emerge once again. So I don't want to just bring up all sorts of problems, but this leads into some of my suggestions, which also gives an overview of some of my research. But first, what I'll say is, I think there's a need for greater awareness of dyslexia policy, how children with dyslexia are being identified in schools, and also the need for database monitoring of school policy and what models they're implementing. Here in South Carolina, I'm leading a large statewide data-based research study where we're collecting data from every school in the state to see how they are specifically identifying kids with learning disabilities. And then we're looking at how their method of identifying kids impacts things like the rate of LD, the reading outcomes of children, and long-term outcomes of reading. So again, what I emphasize here is the need for database monitoring to try to figure out exactly what's working and what's not in schools when we use a multi-method to help with early intervention and identification of kids with disabilities. Again, I also see this as a real benefit of neurocognitive research to inform education-based practice of identifying kids with disabilities. So what I'm interested in is taking the neurocognitive research, like I briefly reviewed for everyone just a minute ago, and say, how can we use this to help inform our multi-tiered systems? And it can lead to a large benefit. So for example, we know that you have to do screening in schools for children with dyslexia, but now we know that phonological, not only is it just screening, but it's phonological based screeners are going to be very important. Additionally, identifying kids with reading problems due to phonology is very important to get them interventions that are reading interventions that focus on phonology. And so again, part of this is looking at how we can infuse more differentiated evaluations of children within a multi-tiered model to help develop targeted interventions. So kind of already, I'll skip through this. And then we can relate, I'm kind of drilling down now, that's kind of at the systems level that this can help understand then our approach to identifying kids with dyslexia, and that we know that with the unexpected problems in learning, there is a discrepancy, but the IQ achievement discrepancy is not the best way of looking at the discrepancy. Instead, what I recommend is looking at the discrepancy just amongst the areas of achievement for a specific child. That is the child's math in the normal range, but reading is discrepant from their math? All right, that's a sign that the child might have a learning disability. Is their reading ability discrepant from their oral language? That is, they know what an apple is, but they can't read the word apple. That's the semantic. When I say oral language, I'm thinking of receptive semantic language. And then also, is there discrepancies with other cognitive abilities? So when we look at a multi-tiered model, we should be screening at the low levels for word level and phonological based problems that kids are having. And that's a really good screening approach. And then when we want to drill down a little more, we got to look at reading specific discrepancies. I call that intra-achievement. We have to look at oral language discrepancies, meaning to do this, we have to know what the child's level of language ability is. And we have to have measures of phonology. There turns out there are also other important specific cognitive abilities that are important for identifying children with dyslexia, one being rapid naming. That is, how fast can the child name objects, which is very important for things like reading fluency, verbal working memory, and also general processing speed. The reason I come up with these areas of discrepancy is because it is informed by the brain-based model that I previously reviewed. Meaning, when we say discrepancies, really what I'm thinking are things like, I'm trying to find what brain regions, the hubs in the network that are working, from the brain regions that are not working. And that's what these discrepancies provide, and that they can be actually measured through behavioral measures that are given usually by school psychologists on a very regular basis. So these are some other implications, is that we know, and I think this is one of the critical things, now that we have a better understanding of dyslexia, we know that phonological awareness, that is the child's capability of understanding sound structures of language, is very important. And we also know phonics, which is letter sound correspondence and word decoding, sight words, and reading fluency are important. More importantly is that we have evidence-based interventions that work. You can find these interventions at places like What Works Clearinghouse, Reading Mastery, Optimized Interventions. So there's a number of places. It's not so much of, are there interventions for different problems? It's, how do we know which child gets what intervention? So for example, if you just use a words, let's say a reading screener at tier 1 to identify kids with reading problems, well, there's a number of children with different types of learning problems that will score low on that. Not only will children with dyslexia score low on it, but children with general language impairment, children with intellectual disabilities, children with attention problems. There's a number of reasons to score low on early reading screening task. To understand why the child's scoring low on it, though, you have to go on to do or obtain some additional ability assessments. And again, phonological awareness, phonics, and some general academic indicators are very important for making these types of discriminations, which will then lead to targeted interventions. Now, from what I said earlier, you might think that might say something like, oh, there are real problems with multi-tiered models, but I'm not. I'd actually say we need to strengthen and promote tiered models of service delivery in schools. but we have to strengthen them and promote them by infusing them with a kind of evidence-based, meaning we have to understand the research on different learning problems, and we have to have evidence for why we're giving one child an intervention and not another child, and that comes from additional diagnostic testing that we can do in children. And I think also I'm raising awareness here that it's okay to be critical and question the effectiveness of tiered approaches in specific schools. That is, really what we need to do is collect evidence locally at the school site to demonstrate that the system's working. And oftentimes schools say, okay, we're going to implement some procedure, they implement it, and it kind of stops there. There's a cycle to this of which not only should you be implementing different services, but collecting data to demonstrate that these services are either working or not. And if they're not working, that data gives you feedback as to things you should change. And again, infusing multi-tiered systems with evidence-based assessments to help guide targeting interventions is of extreme importance. And so certainly this is a critical part where hopefully we can all support research efforts like we're doing here at the universities. So hopefully this gives you a little bit of an overview of some of the challenges involved with specific learning disabilities. And I would also say that it probably can help provide a model that generalizes to the use of multi-tiered models for not just learning disabilities, but all sorts of other disabilities and learning problems that children face in schools. And that also it outlines some of the complexities involved, so that these complexities aren't just a matter of testing a child in school, but it involves things like federal regulations, federal law, state-based policies, how schools are implementing state-based policies, the feedback from parents, and the actual outcomes from children. Hopefully this has also emphasized things like the need for database decision-making and the need to collect data, not just on an individual child or statewide, but at the school level. And also, I want to emphasize that minds matter. Understanding the cognitive processing mechanisms of children help us serve them through intervention and understand the underlying problems that are creating barriers to promoting them to greater learning outcomes. So, thank you for joining me in the webinar. I want to also say that these, what I've covered are solely the opinions of me and don't necessarily represent some of my supporting organizations. Nonetheless, I want to thank the Department of Education here in South Carolina for supporting my research, as well as the University of South Carolina. I've provided my email address here, sdecker@mailbox.sc.edu, in case you have any questions or concerns or comments. So feel free to email me, and I'm happy to end now and open this up for questions if I can figure out how to do questions. So if you have any questions, feel free to post it or email me. Thank you. So I see no open questions, so I'm guessing no questions are being asked. So we'll end it there. Oh, wait, see a question. Wait, okay. And we have a question. Once I can, I'll verbally describe the question and try to answer it on the open mic so everyone can hear it. And Danielle, if I'm missing any, can you send us the PowerPoint? Yes, I can. I don't know exactly how, but I'm guessing the moderator for the webinar will know, and I'll send it to her, Danielle, and she can get it up.
Yes. So I will go ahead and share the PowerPoint to anyone who wants it after this. If you could just share your email in the chat, or you can send it, let's see, so you don't have to. You can send it to me personally in the chat box. There is an option to send it to all panelists or to send it to any specific person. So if you just want to send me your email address, I'll make sure you get it. Dr. Decker, it looks like there's also somebody asking if you have heard of, or how do you feel about Orton Gillingham?
Yeah, so Orton Gillingham's a long-standing intervention that's been used for children with dyslexia, and it's very well structured for children with dyslexia. Here in South Carolina, we have 3 major schools for Orton Gillingham, and I've worked closely with 2 of those schools. And they post really good outcomes. I mean, I hear testimonies of parents who's had children with dyslexia who, had it not been for Orton Gillingham reading interventions, the child's life would have ended up very differently. So there's a lot of good outcomes for Orton Gillingham, and it's strongly supported by a lot of practitioners. Having said that, there has not been a lot of large-scale research studies done with Orton Gillingham. Now, there have been research studies done of other, what I would call spin-offs of Orton Gillingham, which are different types of phonological-based interventions that work well. There's good outcomes with it. And for the most part, what a lot of people would suggest is Orton Gillingham's, which you often have to take a 2-week kind of course to learn how to do it. Some people would say that it's very complex in all the different components to it, and it doesn't have necessarily a systematic way of assessing outcomes. So those are some of the criticisms I've heard of it. Nonetheless, it really does target the phonological processing in a multisensory modality that a lot of people have I've heard really good things about it. Are there situations where we might mistake something else with dyslexia because they appear similar? Yes. So that was part of what I was saying with what you see with, if you just give a basic word level reading test in tier 1 as a screener and then start interventions. A lot of people, and I think there's some support for this, see dyslexia as a subtype of a language problem. It makes some sense because it involves the phonological processing, which is a language component. So I see, and I'm fine with that. I've no problem with that. But what happens is you can have children with phonological based processing, so that's dyslexia. But then you can have children with the phonology problems, but also semantic retrieval problems. That is, they have trouble with language. And then you can start broadening that. And if you broaden that enough, you get a child with a specific language impairment, which is a more general language problem. So that's one example of a condition that it's easy to mistake for dyslexia, because you said, well, this child's having trouble reading. But it might not be due specific to phonology, which is what dyslexia is. It might be due to other things. There are some other conditions too, which like attention problems in children. So there's a lot of different conditions that can be mistaken for dyslexia. But again, with a good diagnostic assessment from a knowledgeable person that understands these different conditions and how it manifests on different tests, they can usually be pretty easily distinguished. Make sense to everybody?
Yeah, also, Dr. Decker, it looks like there were 2 additional questions. One going back to the Orton Gillingham. Can you tell us how long does a child need to have that before there is real progress, and how is it evaluated?
Let me make sure I understood. So I don't see the question. I see another question about RTI, which I'll answer here in a minute. What I heard you say was, how long was it? How long does it take Orton Gillingham to work? Was that?
Yes.
Okay.
And how is it evaluated?
Well, again, if you look at one of the criticisms of Orton Gillingham is it doesn't necessarily, it comes with a number of kind of core Orton Gillingham comes with a whole lot of interventions of different types for different, to get at multisensory phonological learning of reading. It does not come with standardized reading measures to measure progress. That has to come from somewhere else. There are standardized measures of reading progress. There's tons of them out there. So as long as you incorporate that along with the interventions, you can monitor progress. How long does it take? It depends on the extent of the learning problem. There are some children with phonological problems that can be resolved with intense interventions fairly quickly. There are some kids who could have intense interventions for years and still struggle with it. Research doesn't know why there are individual differences in intervention outcomes across these kids. But again, you can probably guess as to what my answer is, which is it depends on the extent of disconnection between the brain networks. So that children that have highly disconnected areas of the brain involving language, they're going to need a lot of intervention to get those structures working again. Whereas there are some kids that kind of have those roads in place and they just need more traffic to strengthen those roads. And once they're strengthened, their phonology takes off. So it's variable.
Okay, thank you.
Yeah, I see another question here. Are schools showing little, no negative results with RTI, rethinking resources they invest in it? I don't know. That's a really good question. I think the going model right now is, I've seen some posts on kind of listservs and some other areas of suggesting that of like, okay, let's try something else. But I haven't seen that as the predominant way of thinking about it. What I've seen instead is what I think I emphasized here in this webinar, which is we're still learning about how to implement multi-tiered systems in schools. There's a lot of fidelity issues and a lot that we can still learn from it. I think what the prevailing wisdom is right now is how do we make it work better, not necessarily what else should we do. That's been my experience.
And it looks like in our chat, somebody has mentioned that they have a kindergarten student who often flips letters and numbers. When should they be concerned about that?
Yeah, so again, this is the real need for standardized tests of reading. One thing that I didn't directly address, but the largest percent, so children with dyslexia, for the most part, have trouble reading due to phonological processing issues. That is different than the kind of common belief that children with dyslexia are kids who flip letters around. It turns out that flipping letters around is fairly normal for most kids. So I forget the exact percentage, but if you look at kids in kindergarten and you ask them to write letters and you look at the number of times a child flips a letter, it's something like 40 to 50% of kids. So it's not something to be concerned about. So that's fairly normal. The core issue is, can they blend words together? So here's an example. You can ask a child something like, if you had the word football and you remove the word foot, what word would you have? And so the answer is ball, but it's great. It's very instructive to watch kids with dyslexia try that, try to take that word, dissect it into two different words, and solve that. To them, it's like a riddle that has no answer. So those are much better indicators of children who might go on to have dyslexia. There's also, now there's no doubt that kids might have what are called orientation problems with letters. And again, there's a developmental trajectory for it such that it's fairly normal at younger ages. And then it kind of, you start seeing a decreasing trend. So when you're in kindergarten, is it an issue? No, not really. Third grade, yeah, that's a little more of an issue. Now there's still, now there's two schools of thoughts on that while we're on it, is that some people would say really what the letter orientation problems are is a type of visual dyslexia that's separate from the phonological type. And it impacts more of things like the orthography. There is probably a subsection of children who have those specific more visual orientation or visual structural types of problems that are causing the reading problems. But of children with problems in reading, it's probably something like 10%. There's another school of thought that would suggest even those children who are having those what appears to be visual processing problems, they're actually having those problems due to an underlying phonological issue that's keeping them from really learning letter symbols and letter sounds. I don't, you know, I think both perspectives are permissible. But again, the answer to those questions come from, you got to get good data from standardized tests that show you what the developmental expectations of learning are for whatever the age of the child is. And that helps guide you more than anything else. Are there any other questions that I'm not seeing on here?
I think that's all. That's all of the questions or comments that have been
Okay.
so far.
So with that, I will close the question box. And again, you got my email if you have any other questions. Thank you so very much for listening to me. Hope you found it interesting and hope you learned something. And have a good day. I'm going to stop sharing now.